All right, solve using the quadratic formula again. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, a equals 1, b equals 1, it's already in standard form, and c equals 1. So, nice simple numbers that I'm working with. X equals negative b, so that's negative 1, plus or minus the square root of b squared, so that's 1 squared, minus 4 times 1 again, so minus 4ac, all over 2 times a, which is 1. So x equals negative 1 plus or minus 1 minus 4 all over 2. So x equals negative 1 plus or minus the square root of 1 minus 4, which is negative 3. Okay, so you can see what happened here is I ended up with a negative number, a negative discriminant. So because it's asking me to take the square root of a negative number, my solutions are going to be a pair of complex conjugates. There's no real solutions, but there are solutions. Recall that I can simplify this to say that negative 1 plus or minus the square root of negative 1 times the square root of 3 over 2. And I'm going to recall that I equals the square root of negative 1. Therefore, x equals negative 1. I'm going to change this into I. Okay, so I had a square root of negative 3. I broke that down into square root of negative 1 times the square root of negative 3, which gives me x equals negative 1 plus or minus I, since this is equal to I, radical 3 all over 2. And I can rewrite that a slightly different way and say x equals negative 1 plus I, radical 3 over 2, and x equals negative 1 minus I, radical 3 all over 2. So looking at this, what I have here are complex conjugates, solutions that are complex conjugates.